All right, so how's everybody doing out there? Well, hopefully everybody did a good job working with our two means with the sigma known. So if you notice the conditions for this one that we're working is with, again, we're still going to be working with two means, but in this case, we're going to know our sample standard deviation. And this is, again, very similar to what we did in 8.5. So step one, nothing different in this case. So again, we're still using mu1, mu2. We still have all the same conditions. So now that we're working with sample standard deviations, we are going to be using tiger scores instead of zebra scores. So if you look at our T sub t, there's nothing really different about that. So we're going to do, again, sample mean 1 minus sample mean 2, all divided by the standard deviations squared, added together, all that good stuff. But notice we are using the sample standard deviation since we have S1 and S2. So now we do want to remember when we're dealing with T intervals or tiger intervals, we have to know the degrees of freedom. And in the one variable case, the degrees of freedom were n minus 1. But notice in this case, the degrees of freedom is pretty much a nightmare. This is a ridiculous formula that we have to use to calculate the degrees of freedom every single time. So luckily for you, I've made a Google Sheet that just allows us to type in the important information. So if we notice, the important information for our degrees of freedom is both sample standard deviations and both sample sizes. So I'll show you when we get to the practice problem, the Google Sheet, and I'll share it with everybody in Teams so you don't have to go through and type this formula because it is awful. So, and again, so easy to make a mistake that's going to mess everything up from that point on. So this is the worst part of the section, but again, with the Google Sheet, it'll make it much, much easier. So, all right. So step three, again, this is identical to what we did last time, except we're swapping out inverse norm for, or normal CDF for TCDF. So again, we still have our two-tailed test, which is, again, multiplied by 2. And then we have our two one-tailed test. Oh, and I guess I forgot to mention up above our T comparison. We're going to be using inverse T instead of inverse norm. And so again, we're either going to use alpha or alpha over 2. And then our degrees of freedom. And so again, depending on whether we use alpha or alpha over 2 depends on whether it's a one-tailed or a two-tailed test. And then finally, draw a conclusion. So these are the same again. P is less than alpha, we reject H naught. If P is greater than alpha, we're going to fail to reject H naught. All right, so let's just take a look at an example here just to see how we do. So for this one, we're comparing diets. So we've got low-fat diets or low-carb diets more effective for weight loss. So a sample of 77 subjects went on a low-carbohydrate diet for 6 months. At the end of that time, the sample mean weight loss was 4.7 kilograms with a sample standard deviation of 7.16 kilograms. A second sample of 79 subjects went on a low-fat diet. Their sample mean weight loss was 2.6 kilograms with a standard deviation of 5.90 kilograms. Can you conclude that the mean weight loss differs between the two diets? Use the alpha equals 0.01 level for this one. All right. So for this one, I'm going to choose kind of the one that came first in terms of numbers. So since we mentioned the low carb diet first, then I'm going to go ahead and use that to be my mu1 and my x1 and all that kind of stuff. So for this one, my mu1 is going to be low carb. And for my mu2, I'm going to use the low fat diet. So again, let's go ahead and jot down everything that we need to know. So our sample mean for the low carb was 4.7 with a sample standard deviation of 7.16, and our N for that was 77. And then for our second sample of 79 subjects, went on a low-fat diet, so their mean weight loss was X2 is equal to 2.6 kilograms with a sample standard deviation of 5.9 and an N of 79. And so again, we're looking at an alpha of 0.01 for this one. So I think we've got everything written down that we need, which is good. And so let's go ahead and look at our claims. So we're trying to conclude that the mean weight loss differs between the two diets. So remember, whenever we're doing differs, that's going to be our equals not equals case. So for this one, our H1 is going to be that mu1 is not equal to mu2. Our H0 is going to be that mu1 equals mu2. All right, so we've got our claims. Let's go ahead and calculate our test statistic in this case. So our T sub T is going to be the two sample means subtracted from each other. So we're going to get 4.7 minus 2.6, all divided by the first sample standard deviation squared, divided by our sample size, plus our second standard deviation squared, divided by our sample size. All right, so let's type this in the calculator, and hopefully I can remember everything here. All right, so 4.16 minus 2.5 divided by square root of, oh, I've already forgot stuff, hold on. Oh, so it's 2.6. So 7.16, 77. Let's fix this to a 6. 7.16 squared divided by 77 plus, oh, hold on, I don't think this is all in the square root. Wait a second. What's going on here? Oh man, this thing's just being contrary. Hold on. I guess I'll retype it. There, divided by 77 plus, let's take a look here. Was it, oops, 5.9 squared, all divided by 79. 5.9 squared divided by 79. All right, so let's delete all this stuff, and I think hopefully I got it right. All right, so it looks like our T sub T score is going to be 1.48 for this one. Oh, no, for some reason I typed this all wrong. Hold on. It should be 4.7. Let's go back and fix this. All right, so there we go. Now I think I finally got it right. So 1.99, or 2, technically, it's rounded up to 2. So our T sub T appears to be even for this, which looks good. All right. So now it's time to find our T sub C. And so since this is a two-tailed test, we want to take our alpha and divide it by 2. So we're going to take our 0.01 divided by 2, and so we're going to get 0.005 is our alpha over 2. So when we do our inverse t, we get 0.005, and then now we need to plug in our degrees of freedom. So again, this is the most complicated part of this, but again, because of the little Google Sheet, it should make life a little bit easier. So what we need to remember is our S1, our S2, our N1, and our N2. So let me go to the Google Sheet here. And so what we're going to do is we're going to type these into that top part where it's SD1, N1, SD2, N2. So let's go ahead and edit this. All right, so our first standard deviation was 7.16 with a 77 in. And then for the next one, I think it was 5.2, wasn't it? Let's see, 5.9. So 5.9. And then 79. And so notice as we're doing it, the degrees of freedom's changing the whole entire time. So it looks like our degrees of freedom are 147. So this, based on the formula, is almost never going to come out to be a whole number. So you can actually type in the decimals, and that's totally fine. I definitely probably wouldn't go more than like 1 or 2 decimals because the difference between these aren't going to make that much difference. So I'm just going to type in 147.1 as my degrees of freedom. My pen's not working. Hold on. Oh, pen still isn't working. Hold on. All right. So if we type this into the calculator, we get inverse t 0.005 comma 147.1 gives us a t sub comparison of negative 2.61. All right, so again, since it's two-tailed, we want to use both of these, the positive and the negative one. And just like before, we're going to reject H naught if it's over here or over here. And we're going to fail to reject. This pen is really not cooperating today. And we're going to fail to reject if it's in the white. And so since this is a positive 2, it's going to be around that area. So it's a little to the left of our comparison score. So it looks like we are going to fail to reject for this one. All right, so let's check our p-value just to confirm that's actually the case. So we're going to use our TCDF for this one. And since our 2 is on the right-hand side of our two-tailed test, we're going to think of this as our lower bound. And some ridiculously big number as our upper bound. And then again, we want to use those same degrees of freedom, so 147.1. And so when we type this in the calculator, we get TCDF, 2 comma some ridiculously big number, comma 147.1. And we see that our p-value is 0.023. Alpha was 0.05, we would actually reject H naught, but unfortunately, since we tried to be a little stricter and went with 0.01, this is actually, oops, not less than, it's actually greater than our 0.01. So in fact, we're going to fail to reject just like we did above. So finally, our conclusion is that it doesn't appear, or there's no significant evidence to say that there is a difference between these two diets. So we fail to reject H naught. There is not sufficient evidence to support the claim that there is a difference between these two diets. All right, so again, other than the degrees of freedom formula being a nightmare, this really isn't that much different than what we did in the very last section. So I do have some more practice problems in this one than the last one. So I've got a couple practice problems. So I'm going to do like we did last time, divide these up amongst different people so we can have people share and kind of work together on these and check each other. And hopefully everybody does good. If you have any questions or need any help, just let me know. Good luck.